So 9.4 is the turning point. And some of you are going to find 9.4, this type of factoring, a lot more difficult than what we did before, because there are multiple possibilities when you start, but only one of them is going to work. So that is what we're going to try to do, is we are going to try to learn a new way to factor. The things that we are doing are all quadratics. So in the previous section, we talked about how these are going to be things that are with a degree of 2. And so since they are all quadratics, and most of them will either be trinomials or binomials, they are all going to factor into a binomial times a binomial in parentheses. Remember, factoring just means turn this thing into multiplication. We're going to turn things that are addition and subtraction into multiplication. Now, there are going to be 3 main things that we're doing on this worksheet 4. We're going to be using the area model. We're going to be doing without the area model, and then we're going to use a technique called difference of squares. Beyond that, there's really not much more other than factoring completely. We'll talk about what that means. So the first thing that I'm going to recommend is that it'll be helpful for you if you write down the notes and you have them alongside you as you're doing the problems. The other thing that will be helpful for you is that you may do some problems with the area model, and then if you get stuck on the guess and check and the factoring, you might want to still continue to use the area model on the other problems below if you need to. But if not, maybe this will help you, because this is the method that I use primarily, but I've been doing this a long time. If this method works for you, use it. And if not, we'll use guess and check. That also works. And then keep in mind, you need to know when there is a binomial that has 2 perfect squares, look for difference of squares. This pattern always holds true. So with that being said, I'm going to reference back to these notes all the time as we get into some problems. I want to do some problems with you. That way you know what we're doing for the area model, what goes where, and then let's figure it out. Guess and check is similar to the area model without drawing the boxes. And so I'm going to show you how that looks in a second. And difference of squares, perfect square, one's negative, one positive, one negative, with the square roots in front and behind. So here we go. Let's do some examples and we'll go from here. I think it'll make a whole lot more sense once we do this stuff. Okay, so in the area model, it says the first thing that the variable squared, this is the variable squared. It goes in the top left box. This is your constant. It goes in the bottom right box. I'm also going to recommend whatever this constant is, if it's minus or positive, put that sign in there. Inside that box, it will make everything easier. Now that you've done that, if you have a product that is x squared, what times what gives you x squared? I hope you realize that x times x is x squared. That's what we're doing. We're basically taking something that's multiplication and are breaking it up into multiplication is what we're doing. Now at this point, you look at 121 and we say what times what is 121. I hope you know that 11 times 11 is 121. And that the only way to multiply to get to a negative 121 is to have one of these as a positive and one of these as a negative. Like that multiplies to be negative 121. And it doesn't matter if you put the negative here or here, it will be the same answer. But what we have left to do is we have these other boxes, so let's multiply the x times the 11. These two things multiply together to be plus 11x. I'll put the sign in there. These two multiply to be negative 11x. And if you were to add these two things together, what you would notice is that a positive 11x, take away 11x, makes 0. So x squared minus 21 minus 121 would be this thing, this length, multiplied by this width. And so we'll write it like this. X plus 11 times x minus 11. If you had the minus over there and the plus over there, then these would be flip-flops, but guess what? Multiplication can be written in any order. So now that you've done the first area model, let's look at the second. Variable squared, other number. Something that I do that I believe is helpful. As we're figuring out what goes where, it might be helpful for you if you start writing out like what multiplies to be 10. 1 times 10, 2 times 5, 5 times 2, 10 times 1. It might be helpful for you if you get into a pickle to start writing out the factors and try to think of all of them, because sometimes you get stuck by only looking at a couple of the factors. So now let's do this problem. What times what is x squared? Hopefully x and x. Now the 10, we could use a 1 times 10 or we could use a 2 times 5. The key to this is looking at your middle term. Your middle term is plus 7x. So you need to know that this diagonal and this diagonal need to add to that. Think of this as the O and the I in FOIL. So what times what is 10? Are you going to use the 1 and the 10? Will that make a 7? Or will the 2 and the 5 make the 7? And I hope you know that using the 2 and the 5. Well, positive or negative 2. Let's put some of those in there. Positive 2 times positive 5 is a positive 10. 2 times x is plus 2x. 5, positive 5 times x is plus 5x. And if you look at these two, x squared, how much does this make together? It makes the middle thing. It makes 7x plus 10. And what you'll see is x plus 2 times the quantity of x plus 5 is equal to x squared plus 7x plus 10. This answer has turned something where you have addition and addition into a group of multiplication. It's all multiply now. X plus 2 times x plus 5. And I would have also accepted x plus 5 times the quantity of x plus 2. It's the same answer. And there we go. So this is the area model. If this method works for you, you can use it later on. But most math teachers do not use this method because of the extra work to draw the boxes and to do the extra work on the outsides to get to the answer. Most of us math teachers, what we do is we do the 2 sets of parentheses. And what we also do is that we write out our possibilities right underneath the 2 excuse me. We write out our possibilities right below, like what times what gives you 7n squared, and what times what gives you 24. A lot of possibilities there. 2 times 12, 3 times 8, 4 times 6, or the other way around. It could also be 6 times 4, 8 times 3, 12 times 2, 24 times 1. Just so you know, it's not necessarily to do front and back on the front, first term, and then on the last term. It's only really appropriate when you have these numbers to just mix up the third term's factors sometimes. So instead of the box, what we're going to try now are those guess and check steps that we wrote down from before. We're going to try to break the trinomial's first term into 2 factors. We're going to try to break the trinomial's last term into 2 factors, and then the middle term should be the O and the I, and we're going to double check with the FOIL and check the signs. So that's where we are. I'm going to try 7n and an n, and what I'm trying to look for is I'm trying to find when I multiply the outside and the inside that we get to a number that's near 13. And because this sucker's negative, this negative 24, one's going to have to be a negative, one's going to have to be a positive. So let's figure out what's going to be where. If I did 7 times 1 and 24. Does 24 take away 7? Does that make 13? It does not. It makes 14. If I did 1 times n and 7 times 24, that's going to be way too big. Let's see, about 12. That's going to be huge. No way. 7 times 2 is 14, and 14, 12 is not going to get us there. So then let's do the 8, 56, and 3, or 21 and 8. What about that one? What about 21 and 8? Here's what I'm doing. I'm looking at this number times that number. That makes 21n. I'm looking at those numbers, and then I'm doing the other number times the inside number, this one right here. And I'm trying to think, what would get me to this number here? If that was negative and this was positive, the O, the outside, plus the inside together should make this middle term. 21, take away 8, 21n, take away 8n, should be 13n. And then, does this times that equal that? If it does, you have found the right combination. You have unlocked the prize. That's the whole goal. The goal is to figure out what times what equals what. And then you could even go back to what we did before. This is going to say check your answer by multiplying. You take your thing, and then I should get the same exact answer going the other way. 21n minus 8n minus 24, 7n squared plus 13n minus 24. Look at how that's the same exact thing when you check by multiplying. That's how it works. So let's do a couple of those. First thing I'm going to do is I know I have to split this up. I know there's different possibilities here. I know that there is 2 times 3, 3 times 2, 1 times 6, and then we have 2s and s, and I don't need to change that order, but I do need to change these orders over here. So this times this is that. What we're looking for, which combination will add to this middle term here? I want somehow, let's see, what the heck, Mr. Paramo? These are the same direction. Let's do it that way. Outside, 2 times 1, 2. 6s and 2s is 8. Doesn't make that. It can't be that one. 12 and 1. 12 and 1 would make 13. So let's try that one. I'm going to circle this. The outside would be 12s. The inside would be 1s. If that was a positive and that was a positive, 2s squared plus 12 plus another one is 13 and plus 6. Eventually, you get really good at double checking these things mentally. But if you are not good at doing that mentally, then you just work it out, FOIL it, double check. Let's do another one. 5n times n. That's the only way to get that one. We're starting off with these nice primes at the beginning for you on purpose. 1 times 6, 2 times 3, 3 times 2, 6 times 1. Negative and a negative, so I'm going to have to deal with some negatives here. I'm going to put the 5n times n here at the beginning of both. The first times the first always is that one. The last times the last should equal that one. And we need to figure out the O and the I that's going to make a 13. 13, let's see here. 10 and a 3. Let's try the 2 and the 3. Let's see. If we do 10 and it was negative, and we did the 3 and it's negative, that would make negative 10n and negative 3n, which makes negative 13. But look at this. If you do negative 3 times negative 2, a negative times a negative is a positive 6, and this is a negative 6, and this is not a typo. You have found something that works in 3 cases. The first, the outside, the inside makes that, but the last does not make that. So the 3 and the 2, you're going to have to cross that off. It does not work. If you think, oh, no, it has to work, it does not have to work every single time. You have to should try something else. So what if I put the 3 there and the 2 there? What if we just switch those 2 things? What if I got negative 15n and I had a positive 2n? Would that add to be to negative 13? And does the positive 2 times a negative 3 equal a negative 6? Oh, see? Now it works. It works because we found the right combination, and not all combinations work. Matter of fact, most of the time there's 3 wrong answers and 1 right answer. So with that being said, always double check by foiling. Which brings us to the difference of squares. Now you don't have a trinomial. Now you have a binomial that is a quadratic. This is a perfect square. This is a perfect square, and there's a subtraction sign. So, if I know what the square root of this is, this times itself is that. And I know what the square root of this is. This times this is that. The only way to get to a negative is to have 1 positive and 1 negative. And that makes the outside a negative 10a and the inside a positive 10a, which means that the O and the I will cancel out. This is the answer to this difference of squares. I'll prove it to you by multiplication, which is part B of this question. 2a times 2a is 4a squared minus 10a plus 10a. Look at how I write it. I line them up so that they can cancel each other out. Same answer. You don't always have to check your answer, only for numbers 15 through 18. So we'll factor this one, and I notice a perfect square and another perfect square. Some extra variables there, but that's not going to deter us. What times what is the first one? What times what is that second one? How about a 5y and a 5y? But to get to that negative, one has to be a positive, and the other one has to be a negative. 9x squared minus 15xy plus 15xy, those would go away, and negative 25y squared. This is the answer. For every difference of squares, when you see a difference of squares, it's the square root of this one times itself, square root of this one times itself, and 1 positive and 1 negative in the parentheses. It turns into a binomial times a binomial. The last thing that you need to do is sometimes it's going to say the words factor completely. Now this word completely is kind of keywords in Clovis Unified as, hey, keep going. Don't forget you may have to do more than one technique. So sometimes you're going to do a GCF first. Pull out a 2 from each of those things. And then if you look at this sucker and you see that, hey, this blue part looks like that thing we were just doing, and I might be able to factor it a little bit further. Yes, you can. What times what is n? What times what is 10? That will add to 12. 10 and 1? No. 5 and 2? Wait a second. I know what I did wrong. I'm sorry. Let me erase Mr. Paramo. Mr. Paramo made a mistake. When I factored out the 2 here, this is the mistake. This is the mistake. Let's go back to red. 2 times n is 2n squared. 2 times 6n would make 12n, and 2 times 5. That times that is that. Okay, there we go. Mr. Paramo is tired. I'm sorry. 2 times what is 6n? 3n. 2 times 3n is 6n. 2 times... No, that's not... No. I am tired, I can tell, because this is the same as what I wrote above it. I just needed to say that because the blue part is what's going to factor. What multiplies to be 5 times 1, and can add to be 6. 5, 1, plus. Outside's 5n, plus 1n is 6n. 1 times 5 is 5. And then, of course, the 2. This is factored completely. Notice that there's a GCF in front of the trinomial that broke apart, and there's the 2 answers. These could be mixed up, of course, with n plus 5 first and the n plus 1 second. It would be the same thing. I'm going to stop your notes right there.